Alright, let's look at another way to find the distance of the line segment here. Okay, we're going to find this distance right here. And last time we used the Pythagorean theorem, but there's going to be a formula for that, just like we had the midpoint formula. Alright, so let's take a look. Again, we found that the distance across here was 6. It's the same problem as before. And the distance here was 8. Now, these 6 and this 8 is related to the points that we have here. Notice we have a -2 and a 4 here. And if you subtract the difference, if we're on the number line at 4 and we jump back to 2, there's a difference of 6 there. So this 6 right here is actually equal to x2, that's this point right here, minus x1, this x-coordinate. So if you subtract the x-coordinates, you get that distance. And likewise, if you subtract the y-coordinates, 1, or -1 and 7, you'll get 8. Okay, so we start at a height of 7, and we go down to -1. That's a distance of 8. So this distance here was found by doing 7 minus -1, or y2 minus y1. Alright, you see that? If you subtract the y-coordinates, you'll get our distance here. And if you subtract the x-coordinates, you'll get our distance here. Why is that important? Well, remember that we ended up squaring these numbers to find the Pythagorean theorem. So let's call this, I know I called it C last time, but I'm going to call it D for distance this time. So this is kind of like A, and this is kind of like B. So watch how I write my new equation now. D squared equals, and A was x2 minus x1 squared, and B was y2 minus y1 squared. And so you ended up squaring them, and then remember at the very last step we took the square root of this side, and then when we added these together we took the square root. Well, we want the distance formula to just have D by itself, so what I'm going to do is I'm going to take the square root of this side and all of this side. Now when I take the square root of the left side, the square root of D squared is just D. And when I take the square root of this side, it doesn't cancel out, contrary to popular belief. Okay, some people think when I take the square root that these squares cancel out. They don't. Everything just stays right where it is. When you do that, you get our distance formula. This right here, remember when I told you to write the midpoint formula down? I would definitely write this distance formula down now. And check out how it works. If I want to find the distance of this line segment right here, okay, let's start this problem over. Pretend I don't know any of this stuff. I'm going to plug everything into the distance formula. The distance of this line is equal to the square root of, big square root, x2 minus x1. Here's x2, 4. Here's x1, minus 2. 4 minus -2 squared plus y2 minus y1. That was 7 minus -1. 7 minus -1 squared. And when I do that, I get distance equals the square root of 4 minus -2. When you minus a negative, they both turn positive, right? So that would end up being 6 squared, which is 36. And over here, same thing, minus a negative will make them both turn positive. And 7 plus 1 is 8. And 8 squared is 64. And so the distance is equal to the square root of 36 plus 64 is 100. And the square root of 100 is 10. So we don't even really have to do the Pythagorean theorem if we don't want to. What we can do is just plug it all into the distance formula that we created. What I want you to understand is that the distance formula right here is essentially the same thing as the Pythagorean theorem. It really is the same thing. This is like a squared, and this is like b squared. And then we just took the square root up front. Okay?